example 1, we have something like this. Use the trigonometric ratio of cosine A equals 0.6 to determine which angle of the triangle is angle A. Well, if I say that cosine A is equal to the adjacent leg over hypotenuse, that means that the cosine is the adjacent over the hypotenuse, remembering, of course, SOHCAHTOA, adjacent over hypotenuse, is given by that. Well, for angle 1, the cosine of angle 1 equals, and I'm going to say adjacent, so that's 3.6, over the hypotenuse, which is 6. The cosine of angle 2 is equal to 4.8 over 6. Calculator time. Which one gives me 0.6? Well, when I calculate this, I have 3.6 divided by 6 gives me 0.6, and the other one gives me 4.8 divided by 6 equals 0.8. So obviously I can see that the cosine of A, if it's equal to 0.6, then angle 1 must be A. I can label it A. Do you see how that worked? If I'm given an angle, I can find the cosine, and that's okay. Because if I can find the cosine, we're going to see in just a minute how we can use that to find a side length. Okay? Now, here's one for you to do. I've given you two things. The sine of A, which we don't know what A is, and the tangent of A, which we don't know what A is. Figure it out based on SOHCAHTOA. And that will help you determine which angle is angle A for A and B. They may be different ones. So try that one. We'll talk about it in class. Let's consider the sine of 30 for a minute. The sine of 30, as we recall, if I draw out this triangle, and this is my 30-degree angle, I know that this is x, this is 2x, and this is square root of 3 times x, given the fact that this is a 90-degree right triangle. The sine of 30 is equal to opposite over hypotenuse, x over 2x, which it equals, after I cross out, 1 over 2. So the sine of 30 is equal to 1/2. That is always true. So what I'm saying is, if we know the sine, the cosine, or the tangent, meaning we have a decimal value for it, we can use inverse ratios. Here's how that works. If sine of A equals x, it follows that sine inverse of x equals A. Sine minus 1 means sine inverse. It's on your calculator. It's the second function. So you hit the yellow button second, and you hit sine, and it'll come up with a sine minus 1. In the same way, if cosine of A equals x, it follows that cosine inverse of x equals A. If, tangent A equals x, it follows that tangent inverse of x equals A. Your calculator has a list of values. If you put in an angle and take the sine of it, it spits out a decimal. Well, if you put the decimal in, it can also work backwards. So that's what we're going to be doing here. In example 2, calculating angle measures from trigonometric ratios. If I take this and punch this into my calculator, I hit second cosine 0.5, enter. It gives me second cosine 0.5, enter. 60 degrees. That makes sense. I'm going to do the same thing for sine inverse. Second sine 0.45 equals 26 nearest degree. This is 26.74 degrees, so that means it's going to go to 27 degrees. In the same way, I'll do tangent inverse. 3.2, 72.64 degrees, which means it goes to 73 degrees thereabouts. Use your calculator to do these inverse ratios. It has a chart in here that you can use. Use it. Because when you do sine inverse, it's saying, I have this decimal value. Please give me the angle. In the same way you could say, take the sine of this angle. Please give me the decimal. It works backwards. Try this one. The next step to this is to apply it overall to the triangle to find the angles and the sides. We're going to do that next time. Thank you for watching. We'll see you next time.